All right. It looks like we are actually live. The synchronization between when you say go and it actually goes always confuses the heck out of me. But welcome to my live stream. I'm going to be talking about my last video, which was the automatic bow. And this was a really big project. This was probably about 2 months of work, and there's so much that just did not make the cut in the video. I had eight 8 terabytes of footage from this. I filmed everything in 4K, 60 frames per second, and there's just an enormous amount of stuff. So I'm going to play through the video, and I'm going to pause whenever I think there's something interesting or more light I can shed on a subject, but also feel free to ask questions in the comments. I'll try to answer as many of those as I can, and hopefully this will be interesting. So it looks like we have enough people here, and I'm going to just go into it. So let's play the video. No looking William Tell.
Oh.
My wife did archery growing up. I did not. But being good at stuff is so 20th century. Put this on, and you don't have to aim anymore. So I guess I made an aimbot. When you wield the aimbot, you almost... So there's one cool little detail that I really wanted to talk about in the video, but I didn't get to, which is this sort of metal foil looking thing on top of the bow. This is a spring. It's called a constant force spring, and it's like a tape measure. No matter how far you pull it out, it always pulls with the same force. And what this does is it offsets the weight of the bow for the motor that lifts up and down. Without it, it's really unreliable. And this basically makes it so that it's only having to accelerate or decelerate the mass. It's not having to lift it. When you wield the aimbot, you almost have a superpower. It tracks targets really well. Almost as well as my dog can track treats. It moves the bow to correct for your lousy aim. And when everything is perfectly lined up, going into this, I wanted to shoot bullseyes.
Lame.
Multiple bullseyes,
Still lame.
which led to bullseyes flying through the air. So we're gonna try all that and maybe hit the world's smallest William Tell.
Sweet.
So a lot of people have asked me if that's staged or scripted, but she just did that. It's pretty funny, but yeah, no staging there. And then on the multiple bullseyes and targets flying through the air, the original plan for this, I've been thinking about this for at least a year, probably longer than that. What I wanted to do was just have like a bow with cameras in it or something so that I could just hit bullseyes that are static. The idea of a bullseye flying through the air is super cool, but it's also really, really hard because if you only have a bow that has sensors that are in the bow, like cameras and whatever, you have a really hard time figuring out where something actually is. So if you have a target flying through the air, it's pretty easy to tell if you're pointing at it, but it's hard to tell how far away it is and what path in space it's actually taking, which is information that you need to lead it correctly and all of that. So I was going to do static bullseyes. I got these OptiTrack cameras, which can do the external tracking really well. That's what pushed me over the edge to do flying targets. And then they became the limitation, though, because they don't work outside. The sun overpowers them. And so it had to be done indoors. And that basically dictated the parameters of the project. But I think it was really cool. This project started when I realized there's a hole in my heart that money just couldn't fill.
It's 2021 and I can't buy a self-aiming bow.
So I built it. It works now, but it took me thousands of misses to get here. There was also some collateral damage. The progression of my backstop for the arrows is something that I wanted to talk about in the video, but it just didn't really fit. The amount of bins and other things that I just destroyed is really, really high. I ultimately ended up with a super thick moving blanket with a target behind it if I had an idea of where I might be missing, and then sheets of plywood. and I still had arrows go all the way through that entire stack up. And this is actually also part of the reason why a lot of people commented on how bad my form was, and if I pulled the bow back the proper distance, I wouldn't punch myself in the face. And that's what you want to do. You want to do what's called a cheek weld, where you stabilize your backhand against your cheek. But I was trying to keep the draw force of the bow down so I would destroy less things when I missed. And so for the compound bow, you can adjust the draw length and you can adjust the draw force, which tells you how fast the arrow is going to go, but they kind of go together. So if you want it to be lower force so that you're not shooting as fast, you're pulling it like a child. And that's why I was pulling it to here. It's not that I didn't know. It's just that I'd rather do that and hit myself than destroy a bunch of stuff. Although my nose probably took the biggest beating. So let me show you why an aimbot is hard. Hey, what are we gonna do? So this TV is CNC machined on my router. It's made out of a sheet of MDF. Some people thought that I 3D printed it or something, but I didn't. And I had to machine it because I could not find a TV. I drove around to a bunch of thrift stores. None of them had a TV. And so this is some model off of GrabCAD. And the knobs are SLA printed on the Form 3, and then the machine is done on the 24R, or the body is done on the 24R. And this sequence, I had a vision. It's like, okay, I want to make it like this old-timey TV thing. It'd be kind of funny and a neat challenge. But this took me so long to get convincing, because if you just take the video and scale it down and put it in a TV, like, it just looks completely fake. And I found some plugin that was advertised as turn your amazing HD footage into analog garbage. So that helped a lot, but I had to add the glow from the footage on the bezel and reflection of the glass on the screen. And without that, it was so fake. It was just stupid. And this probably added like a day and a half to 2 days to the whole editing process. So yeah, I don't know, it probably wasn't worth it, but I had a lot of fun making it, which is, I guess, that's what happens with all these projects. They're not really worth it, but they're a lot of fun.
Archery.
All right, a lot of stuff just happened. Most importantly, the arrow flew in a curved path. The big thing that I was concerned with, let's see. One thing I was really concerned about with this sequence is how can I make it, like, if I'm going to do any kind of illustration in the video, how can I make it not seem like a weird anachronism? Like, if I animate on top of the screen of the TV, it like completely takes you out of it. And so I did some tests, and I was able to basically do the animation and then cruftify that, and then it made it look like it was some old-timey like 1940s Department of Energy or Department of War video when they teach about transmissions or something. And so that worked out really nicely. But yeah, way too much time went into this. Aiming above the target, so when the arrow curved down, it would hit the right spot. The arrow curves more or less depending on how fast it's going. If her hands are off by even a couple of millimeters, she will miss. And like this zooming, the VHS is super low res, so how do you show an arrow that's missing and stuff like that? That's all fake. So it's just high res 4K footage that I'm cropping and zooming and trying to make it so you can see what the heck is going on without breaking the illusion. If her hands are off by even a couple of millimeters, she will miss. 3, 2, 1. And she really did that. You can't aim for where the target is because it won't be there when the arrow reaches it. You have to shoot where the target will be, which is called leading. But what's really hard is the timing. This arrow was fired 50 milliseconds too late. Isn't that crazy? 50 milliseconds. And that's actually, I'm saying that the window is 50 milliseconds, but that arrow, 50 milliseconds is way missed. It's actually probably more like plus or minus 20. If you want to hit the target, maybe even a little tighter than that. It's shockingly narrow, the window.
That's 1/3 of the time that a blink takes. Let me show you 50 milliseconds.
That was actually 20 milliseconds. I didn't realize that I was exporting the video in 60 frames per second. And apparently a lot of people on YouTube actually counted the frames and called me out on my BS timing. I didn't mean to make it wrong, but oops.
Did you even see that? Let me do it again. She has to fire within that window of time if she wants to hit the target. It's crazy. And I want to hit moving targets too, so my aimbot is going to have to do this. This is going to be hard.
Nice job. I mean, 2 out of...
So yeah, people are asking how long did it take me to perfect my mid-90s look. It was self-evident. It was pretty clear that you needed a mullet and a stash. We have lots of home videos of my dad, so it was like, all right, well, I just got to do what he had, and it'll work perfectly, and it did. The in high res 4K, it looks really ridiculous, but when you add the tape, it just seems right. I don't know. It's amazing.
The 3.
All right, that's enough. My plan is to make a little robot that goes between my hand and the bow. It will move the bow so that everything is lined up just right, and there will be an even tinier robot in my other hand, which can release. So the brainstorming phase for this thing was actually pretty long. So I said this was a 2-month project. I probably spent a good week trying to figure out how I could possibly make this device so that I could hold it, so that it could handle the forces. And the big problem in all of this, if we go back to this view, is that if you're drawing this bow as I've illustrated it here, I can't actually, but one of the things I was really concerned about, which was actually a big limitation, is that even when you put the gauntlet on, when you pull way out here, your arm is not made to withstand that kind of torque. It really messes up your elbow. And so when I went into this, I was concerned that it was going to like literally pull my elbow apart or something. So I built a little wooden I went on the router and I made not origami, but I made out of sheets, I assembled a thingy, which was a gauntlet that would allow me to hold a bow offset in a variety of different distances from my arm. So I could test it before I went and built this whole thing. And I found that I could go maybe 3 inches, 3.5. Beyond that, it just completely was like, it was really painful. And even the 3 inches, if I did it a lot, like my elbow would be really sore the next day. And so that's a big limitation of this. And then the other thing is that even when you have the gauntlet and your elbow can survive, it wants to pull your arm in. Like it's a weird force that you don't normally have on your arm. And so it's challenging to hold it for a long time if it's fully extended. So the robot tries to not extend over there unless it has to, because you just can't bear it for very long. The bow. It will move the bow so that everything is lined up just right, and there will be an even tinier robot in my other hand, which can release the string to fire the bow. All right, and then one other little note on all this. The little squeaky release, that turned out to be a big problem with this bow. Something that I did not appreciate is how incredibly important any motion that happens like 50, I don't know how many milliseconds, probably on the order of 10 to 50 milliseconds after you release, completely influences where the arrow goes. So if I flinch after it releases, I can actually make the arrow hit a different spot. And even if the arrow is not touching the bow, if I tweak the bow, it makes the string pushing on the arrow push on a different vector, and it'll whip the tail of the arrow around and do all kinds of weird stuff. And so I was using this little servo that took on the order of 200 milliseconds to open, and my body would hear it starting to open, I guess, and it would flinch. Like I would know it was coming and I would flinch, and then the arrow would just completely miss. And so it actually took me a while to teach myself not to pay any attention, and I was most accurate. So that slow-mo series where I shoot like 10 arrows into the bullseye, that was me not paying any attention. I was looking back and like talking to the wall while it did its thing, and it would shoot. So I wasn't gonna do anything to mess it up. It's kind of interesting.
The core idea behind this is pretty straightforward, but actually designing and making this is going to be a challenge.
The engineering tunes, that was made on my wife's Cricut. If you haven't seen a Cricut, they are actually an amazing tool. I usually can do what I need on the laser cutter, but yeah, they can cut balsa, they can cut vinyl, they can cut plastic sheeting, fabrics, all kinds of stuff. And they're super easy to use. I recommend them. They're really nice. This is, I don't think I talked about this in my last video. So the parts come out of the fuse. That's the SLS nylon printer. And they come out of it. You can usually get all the powder off of most of the stuff just with a brush. But if you have any kind of crevasses or cracks or anything, bead blasting it is 10 times easier than trying to do anything with a brush. So this is a little tiny bead blasting cabinet, and most of the parts that come out of it, I'll bead blast them. You can get them cleaner with a really nice surface finish this way. And it's this fits basically any part that you can fit in the fuse. So it's not nearly as bad as I thought. I was worried I was gonna have a huge blast cabinet dedicated to this, but this is just a little bench thing. So basically all the parts that I was machining in this project were to adapt these pancake BLDCs to do what I needed to do. So this is a motor for a large drone, and these motors are designed to have a propeller bolted directly to them, so they don't even have a shaft coming out of them. And so I needed a shaft that I could mount a pinion on, and also that was long enough to go to an encoder for the feedback. That's how these are controlled. I was trying to use an ODrive, which is a open source brushless motor to closed loop BLDC conversion thingy. And it's really good, super fast, super powerful, and I couldn't get it working, but it shows great promise. So, oops. So the ODrive is down here. And then this is just one of the newer Arduinos. I think it's an Arduino Metro. All I needed it to do was to trigger the servo and listen to the button. So I didn't need much there. And then I guess this was another, since we're on the topic of the design still, this rail was probably the hardest part of this entire project, because if you think about it, I have this rail which can extend out several inches out, and that's trying to bend this entire assembly. Like, this nylon arm just wants to just snap in half, or at least deflect really bad. And that made designing this nylon arm so that it was strong enough a challenge, but then you run into issues with these rails as well. So when you twist this whole assembly and crank it down, the surface that these little rails are mounted to will distort, and then they'll start to bind up. They really need to not move relative to each other. So this whole part of the gauntlet is wildly overbuilt. It is super stiff. It's ultra ribbed. This is full of ribs. And this part here is really, really stiff too, to try to avoid twisting the blocks relative to each other. Like, I don't want the arm to form an S shape. It's really important that that doesn't happen. So that's, yeah, it's probably beefier than it needs to be, but I didn't want to have to remake it. And then all of the important surfaces on the nylon parts are machined. So I print it and then I post machined them so they'd be flat and parallel and everything. And that's a really good technique for 3D printed parts. You can print the net thing kind of like a casting and then machine to get things really square or whatever. Works on FDM parts, SLA parts, and SLS parts. So that was basically the representative issue with the O drive. I spent at least a week on this, and it was part my setup. There was some issues with, I don't want to go too deep into this, but the encoder, which is the thing that tells the computer how much the shaft is rotated. There's some issues if you're using an encoder that isn't absolute. So if you power cycle it, it doesn't know where it's at. The machine needs to do a special routine to figure out where the heck the encoder's at. And then because the bow, the configuration of it is the motors are basically always loaded. And so it's very difficult to do these routines. And then I was having issues where I was effectively stalling the motors for a bunch of different reasons. And these motors are made for a quadcopter with a propeller blowing air over them constantly, which isn't happening here. So when I run them at their max rated current, they can really only do that for a little bit before they overheat. And so I could do it for a spike to move the bow and fire because that's a really short event. But if they would stall, they would burn up. So I destroyed a few. I saw the ribs have ribs. That's how you know you made it in life. Anyway, I destroyed a few motors and then I just kind of gave up on them. I want to go back to it. It's a really great board, and it can way outperform the stepper motors that I used, which was sad, but I just had to get this thing done.
Oh.
I spent over a week on the spontaneous combustion issue. We're not even going to talk about it, other than to say it's fixed. So you can see, well,
You
not
slide
from this
it on
view.
like this.
Yeah, you can see my square peg in the round hole. This is actually, I was able to completely rework this on the mill. So this is super duper, drilled a bunch of holes and machined some pockets and stuff to fit the stepper motor. This one, I just printed this part and I was able to get it working. It can aim the bow up and down with this linear axis. You can actually, oops, sorry, I'm not great at these controls. So that spring that I was talking about, the constant force spring, you can see it working here pretty well, and left and right with this one. There's a little Kevlar line that's going to the top of this assembly. This is actually, very luckily, I didn't design it this way, but this is basically the center of mass. So I'm pulling right through the center of mass, so nothing is twisting or anything. And this also helped a lot with the torques on these, at least in one plane. But the twisting sort of about my forearm, like the axis formed by my arm, that one is also significant, not just the bending back. And so this helps to null that one out. Here's the little robot that releases the string. It does this with a little servo motor. It is super important that the bow always points at my back hand. If it doesn't, then the arrows just don't fly right at all. The arrows with this cheapo bow, the arrows look like that when you launch them normally. Not quite as bad, but these bows don't have enough of a cutout for the arrows to be in line with the string. And boy, do they flex and go crazy when you fire them.
The aimbot hardware is done, but at this point it's pretty much just a crappy heavy bow.
I need some kind of sensor that tells me where the bow is relative to the target and a lot of other stuff. There's 8 cameras throughout my shop that see everything. They're made by a company called OptiTrack. I cannot get over how amazingly good these cameras are. The amount of time that I've spent trying to make crappy tracking systems with the Kinect or with the Intel RealSense or 2D cameras, these things, you literally just stick them anywhere, put them on a tripod, screw them to the ceiling, it doesn't matter. And then you walk around with the wand and they work. Like, that's it. Sometimes you have to do the calibration a couple times if you don't have them set up right, but it is so much easier. It is really a shame that this technology is so expensive because, I don't know, if more people had it, I think there's a lot of really cool things you could do with it. Here's how it works. If I hold up this little reflective ball, it's seen by all the cameras at the same time. Imagine this is the ball that I'm holding up, and a camera's looking at it from this angle. The camera will take a picture that looks like this. If you project an imaginary tube out from the ball in the image, we know that the ball must be in that tube. We just don't know how far away it is from the image. If we add another camera looking at the ball from this angle, we get another tube that the ball could be in, and the intersection of these tubes gives us the location of the ball.
And these cameras...
The detail that I'm glossing over in all of this is that you need to know where the cameras are. And so that's what the wanding is. You have a stick with balls that are known locations relative to each other. And when you wave that all around, you get a ton of pictures from all the different cameras. And then they can look at basically the correlation between the different views of the thing of known geometry. And then it does basically an optimization where it figures out the locations in space for the cameras that would make what they're seeing make sense. And so you can actually see it when you calibrate it. It renders it in real time. The cameras are like, bleh, they're like nowhere, and you can see them iteratively move to the right spots as the calculation converges. So it's pretty cool. And Raya is asking if the balls are retroreflective. Yeah. So basically anything that's retroreflective works. I shot some of these balls out of my catapults in the last video, and those were actually steel ball bearings, but I bought this. I think it's made by 3M. It's a retroreflective spray that you can, I think people put it on their license plates so that you can't see them with the license plate cameras, but they make something you can spray on your clothes that it's basically invisible. I think it's some kind of glass bead, but when you take a picture of it with a flash, you glow like crazy. And so, yeah, you can also buy tapes and other things, and that's how I plan to track the basketball for my next basketball hoop, is just put some tape on it, and then I know where it is. And then the other really cool thing about this software that I didn't really talk about in the video is you can just say, all right, these 3 markers, these will always, it's the right way to say this. If you see 3 markers in this relative positions to each other, that's this object. So you can stick them on something in any arrangement, and then in the software, select them and say, like, this is the bow. And then the software will just wait until it sees something where it matches that arrangement, and then it'll say, all right, here's your bow. And then it'll tell you the orientation of it, and it's all very automagic. And so if you put a bunch of stickers on a basketball, it'll just be like, here's your basketball, and you don't have to do anything. It is, the whole time I was using this, I just was like, man, this is so good. If only I had this 5 years ago.
Cameras do this super fast. In the time that it takes to blink, they'll give me 50 updates on the location of this ball.
360 frames per second. If you, something to look for, I think it made it in the final video, my high-speed camera is sensitive to the strobes on these lights. So I don't think I mentioned this, but they strobe a high-powered LED, which is IR, and then that's what reflects back. And then they coordinate so they don't flash at the same time. But you can see them flashing in my high-speed video to get an idea of how fast they're capturing frames.
It's bananas.
You call these balls markers if you want it to sound like you know what you're talking about. Those markers are, I think, $10 a piece, so you don't want to break them. Tracking balls on the front of the bow, the little grip robot, and on the target. This lets it know where the bow is pointing, how far it's drawn back, and where the target is. I wrote a really simple program to track everything and shoot at stationary targets. So what this program was basically just doing the simplest possible thing, where it was not taking into account any of the dynamics. It was just saying, here's the target, my bow is pointing here. If I want the vector of my arrow to intersect with that point, I need to move it here, and then it would move it there, and then it just did that in a loop, so it would continually adapt where it was moving to, and then it had some gains. It was basically a PID, and then it was accounting for the drop, but I was close enough that the the drop didn't really matter compared to how inaccurate it was. It's time to see what this thing can do. Yep, that hurt. I actually cut my face. I don't know if it's visible in the video. There's actually another big problem, which is that the part that, let's see if I can show this. I can't put my mouse on that. The part that moves next to my knuckles, I designed it like 1 millimeter too close to my knuckles. And so sometimes it would just like cheese grater my knuckles. And so my knuckle got really messed up. I tried to file it down and stuff, but I couldn't take off enough material. And so throughout the project, my knuckle got increasingly bloody and nasty. And there was a couple shots where it's a close-up of my hand and it's like really disgusting looking. And through the power of computer wizardry and special effects, I removed the gore because it was too disgusting. And so if you look closely at the right spots, you can see the signs of my manipulation of the video. But there was another idea that I was going to talk about, but it's lost. We'll keep going.
I'm putting all that force into the string, and then it releases without any warning, and I punch myself. I'm trying really hard not to punch myself, but I punch myself.
Yeah, like you can, this was interesting. You can say like, I'm not going to punch myself, but this happens faster than you can react. Like by the time you even notice that it's fired, you've already punched yourself. So there's nothing you can do about it other than maybe tying a string or doing it in a different way where you're not drawing it with so much tension in your arm, but I really couldn't find a way. Oh yeah, and it's also totally missing.
I really should probably move these out of the way.
I wanted to communicate my struggle with this problem, so I made a movie trailer? I don't even know anymore. Some say he's still in there. Please tell me that was a fluke. Do you ever plan to let me go? Why won't you just work? So, I don't know exactly how I ended up making that. I think there was a confluence of a few different things. For one, I discovered a pack of sound effects from all the movie trailers, like the ridiculous bass drop sound and the kuh, kuh, kuh. And I really wanted to use those. And then I was thinking about how I had the I know what you did last week joke in there, which I thought was kind of funny because that's basically I spent a week on that problem. And then I was thinking about how hellish it was, and it just kind of all came together. And I was like, oh, well, I can maybe cast a mood with a movie trailer or something. It was a fun little diversion. I don't know how effective it was, but a lot of the stuff in these videos just, you know, it's interesting and fun and hopefully entertaining. That was my week. I was stuck in integration hell where all the pieces work by themselves, but you put them together and they try to kill each other, just like children. The biggest problem is that it just won't shoot the right spot. So I haven't proven conclusively why this happens. I'm pretty sure that this was the Archer's paradox. I recorded a bunch of data and it basically, I show a visualization of it later. In fact, it might even be here. Let's see. It is shooting up and to the left almost every time. I could shift things over in software,
But if I do that,
I guess I don't show it till later. I'll point it out if I remember. But there's a visualization that shows the data I collected where it shows where the arrow is pointing, where the target is, the bow is aiming right at the target. Everything's perfect, but it goes to the left. So I'm pretty sure that this is basically the arrow whipping around the bow and getting shoved to the left and just hitting up into the left.
I'm going to just hide a bug that's going to bite me later.
But I won't tell if you don't.
All right, let's put this thing to the test.
Hey, wife. Auto bow versus wife. 3 shots each. Best shot gets the point.
Come on.
She's very pregnant, so she had some difficulty with the bow. And then the other thing that was actually really hard for her is that archers never ever shoot anything this close. This is like 20 feet or something. That is just not something you do. And so I think it's outside of intuition and other things that they're used to. But she still did pretty well.
And here we go. I need my binoculars.
Oh, I'm closer.
Depends on how you measure it.
I had a valid point there, so I cut it out because it wasn't interesting. But I'll say it now, which is I was claiming that if you use the Manhattan distance, I might be closer. If you're not familiar with the Manhattan distance, you can look it up. But there are other ways of measuring it that might make me the winner. Just saying. Darn, I thought I was closer. I was hoping for like a tie or something. But wait.
If I hit this, I win everything.
Did you go around looking for the biggest apple you could possibly find?
No.
So the way this setup worked is, I think some people have asked me, but I don't think I've really elaborated. So this table has markers on the 4 corners of it, here, and then you can't see the other 2. And I basically, from this, I know what direction up is, and then I know where the center of the table is. So if I put the head in the center of the table and I know how tall my head is, I can deduce where the apple must be. And so that's how I'm doing it. What I was originally going to do is put markers on the head and then maybe like around the apple or something. And what I really wanted to do was launch the head through the air and hit the apple off it. But I didn't end up doing that because I didn't have a head launcher. So I was either going to have my wife down there throwing the head over and over again while I tuned my code and got it working, or I was going to have to build a head launcher, which I didn't feel like doing. And so I just went with the static head and called it a day. There's obviously some room for improvement here. You can see the markers
cool for you
leaping.
to fire it.
Yeah, maybe. Is it going to make me miss?
No, it's not going to hurt your aiming.
Grip error. Check hand.
Ow.
I was really disappointed. I was hoping she'd really get clonked right in the face. And actually the reason she said ouch wasn't from punching herself in the neck. It was she was holding the grip with her finger directly behind the servo horn for the servo. And there's a piece of music wire that connects the release to the servo, and that stabbed her directly in the finger. Just went like, is really sharp from cutting it with the plier or with the diagonal cutter, so it just went straight into her finger like a knife. So that's kind of a double whammy, I guess.
Quit hitting yourself. Quit hitting yourself. Quit hitting yourself.
We got a bit sidetracked there. Let's get back to making this work.
The bow is just not shooting the right point. I'm pretty sure it has something to do with the software.
So there's a third monitor joke here that I really enjoyed. Someone was asking how much joy I get out of thinking of those third monitor gags. It is extremely satisfying when you have just the perfect thing to put on your monitor that is related to what you're doing. It is a source of great satisfaction. It's one of those things where you can spend a lot of time just like thinking about it. I try not to. Usually I'll be working on the project and thinking about what I'm going to show and what the story is and everything. And then I'll be like, oh, that would be perfect to put on the monitor. I write it down and then I do it later. That's usually how it happens. And then Michael is asking, where do I rank this project in my list of most dangerous creations? I don't think this was particularly dangerous. The reason why I say that is there's certain things like the bat. Those can they can be armed or they can have energy in them. Like they can have a shell that didn't fire or something like that, and you don't know it. And you can walk in front of it or put your hand on it or something, and then it can blow and unexpectedly maul you. A bow, you have to draw it back. There's no way to leave the bow drawn. Like I can't draw it and then go walk in front of it or mess with the code or something like that. I'm holding it. And so the only way that it can really hurt me is if like the bow exploded. Now I could shoot someone else, but if you are treating the range as a range and you just never have anyone down range when anything is active, it's pretty easy to be safe that way. So I think, even a project where I use the table saw a lot compared to this one is a lot more dangerous than this project. But I'm not going to debug this and try to figure it out. I still need to make the bow track moving targets and all of that. So I'm going to just nuke all of this code and hopefully replace all of these old problems with new and exciting problems. So this was actually an intentional choice. I had never interfaced with the OptiTrack before or anything, and so when there's a lot of unknowns when you're going into a project, whether it's CAD or software or something else, you don't know enough to write it in a sensible way, and unless you just continually rewrite it as you go. And so what I did here, and what I do with a lot of projects, is I just go for it and try to get a prototype working, and then I'll throw it away and redo it, and then I know enough to actually do it in a pretty good way. And this was so, even just with that pretty simple program, it was crufty and terrible, and it would be really hard to add more stuff. So this is a good technique. Most of the stuff I CAD, I will just go in and do the worst solid modeling you've ever seen just to figure out the shapes and sizes of everything. In architecture, I think they call this massing, and then I'll redo it once I have that, and then I can do it a lot better. 1 week later, and I have nothing to show you because software development is very boring, but it's ready to test, and I have a super awesome voice-activated target launcher. All right, pull. In the next 500 milliseconds, a lot is going to happen. The bow is drawn and ready to fire. I'm pressing this button, which tells the computer to fire at will. The tape on the back of the grip is to try to protect my face, so I stop cutting it. I really like how this sequence turned out. I was trying to explain what was happening without just drawing it on the iPad. I like drawing on the iPad, but I don't know, it gets old, and it doesn't force me to try to learn new techniques and different ways of communicating. So I was trying to communicate it all with a series of slow-mo shots of what goes on, and I think it mostly works, although I was limited how deep I could go just because, it's hard to illustrate some of these things. The tracking system sends the computer an update on where everything is every 3 milliseconds. When the computer sees a target, it checks to see if it's moving in a parabolic motion. So yeah, what's going on here? What's the best way to break this down? So the computer is, every time it gets a data point from the target, there's a couple problems. The first is that if the target isn't moving, so you can imagine, let's see, I need to think this through. Okay, so what you want to do is you have a bunch of locations that the target has been in at some time. And you want to say, if I fit a parabolic shape to this, how well does that parabola fit? In particular, does the curvature that the parabola has, is it consistent with gravity? Like that would indicate it's following a ballistic path. And what you don't want to do is collect a bunch of points where it's sitting still before it's been launched. It starts to get launched. You try to fit to it, but there's a bunch of points that aren't a parabolic trajectory connected to points that are. So you want to detect it moving in a parabolic trajectory immediately when that happens and reject all that other stuff. So there's a number of heuristics where if it's not moving, if the fit is terrible, it will just throw away points that it's collected, and then it'll look at a portion of it and see if that looks like a parabola. And then at some point, that fit is good. It usually takes a few points, like 4 or 5, and then it'll chop off everything before that, and it'll kind of lock onto that, and then start broadcasting forward. And this works really well, especially with these cameras because they're so accurate. They have really good time resolution, really good spatial resolution. And I also can calibrate it so that gravity is actually aligned with the z-axis of the coordinate system. So you end up with basically the z motion is a parabola, xy are just lines because it's just moving linearly in xy. And then from that, you can start doing predictions of where it's going to go. That's what the red line is. And then it does a tedious little calculation to figure out where it should move the bow to intercept the target, taking into account the time to move there, release the arrow, reach the target, and the curved path of the arrow. This was a really annoying computation. I actually couldn't find a reasonable way to compute this other than to sample. So what I do is I say, I kind of have to do it backwards. So I don't want to check any points that I could not travel to with the bow. Like if I look at the point 1 millimeter in front of the target, I can't physically move the bow so that it's pointing there before the target gets there. So the first thing I'm trying to figure out is what's the first point that I could possibly move the bow and aim at before the target passes that point. So I try to calculate that, and then I start at that point, and then I march forward every like few millimeters, and I say, okay, if I wanted to hit the target when it was here, where would I need the bow to be pointing? And then I just keep going along the curve, and I try to find the point that is the slowest velocity of the target. So if I can get up to like apogee, the target goes up and slows down and then comes back down. If I can shoot it there, that's the easiest point to hit it. And so that's its first preference. Sometimes it's just too high, or that's really far away and it can't reach it. I actually shot over my backstop a number of times, which is pretty funny. And so it does that. And then it says, okay, if I can't hit apogee, what's the closest point? So rather than trying to move up and intercept it just after apogee or something like that, if it's going to go up and over, can I just move to the left and then intercept it? If it can do that, it'll prefer to do that. And then basically it calculates based on the draw of the bow, how fast the arrow is going to be going, and then how long it takes the little servo thing to release, and then how fast the target's going, and I guess those are the main things. And that's how much it has to lead, how much time it has to lead. And so getting this all dialed, especially getting the calculation for how fast the arrow is going to go versus draw, was critical. I had some approximations for the release time and the flight speed, and it would always miss. I had to measure these, and once I got those dialed, it was really quite good. With the recurve bow, it would basically, it was just like the target. It was always to the side, and I think that's because of the Archer's paradox. This takes about 1,000th of a second, and then it starts moving the bow. And then it repeats this over and over again as more tracking data comes in, which allows it to adapt for things like the shaking of my hands. Oh yeah, so that's one other aspect of this. So there's a point where it's trying to go to intercept the target. As more data comes in from the target moving, it refines the prediction of where the target's going to be. And then also my hands move, especially when it launches the bow to the side with the motors, it pushes off my hand, and it often moves like 75% of the distance that it was trying to go because it pushes my hand away. And so every iteration, every 360th of a second, it will re-update the target. And then it was effectively running a PID. There was a little bit more going on in the controller. In particular, it was looking at the motion of the bow. So if the bow is, if I fit, it's the easiest way to say this. If I know that the bow is moving sideways at 0.5 meters per second when it's going to release, after I release, it will actually be in a different spot than I was when I went to release it. And so it will account for that. It'll look forward not only to where the target is in the leading, it'll look forward to where the bow will be based on the motion of my hand to zero that out as well. And so that works pretty well as long as I'm not like vibrating my hand. If I'm moving the bow or changing speed faster than a couple hundred milliseconds, which I don't really do, then it breaks down. But that was a nice little addition. When it thinks it's aiming at just the right point, it waits until the timing is just right, and then completely misses. I don't know why I love that joke. It's so good. I've probably seen that 500 times. It's still hilarious. Someone's asking, do I take the pull force into account when calculating the speed of the arrow? Yes. So what I did is I had a fish scale and I measured the pull force of the recurve bow at a bunch of different locations, and it was extremely linear. It was much linear than I was expecting it to be. And then I used that to calculate the stored energy in the bow. And then I looked up online how much of that transfers to the arrow as a correction factor. And then I computed the speed. Knowing the weight of the arrow, I was able to compute the speed. And then comparing my prediction of the speed to the actual speed with the high speed camera, it was really accurate. It was within like half a meter per second, roughly. And then the thing that I wanted to do, which I just never got around to doing, is that the cameras are fast enough to track the arrow. Like you can put a tracking ball on the arrow and not only get its trajectory, but its speed and everything else. The reason I actually did this a couple times, it was hard to make an arrow where you wouldn't destroy the tracking ball. And then of course the tracking ball changes your results. So I just never really did it, but that would have been a cool way to collect a bunch of data from a bunch of shots and get a really accurate prediction of the speed.
Life Catapult was getting pretty tired of waiting an hour for me to fix a bug that I said would only take a minute. So I built this automatic catapult that's going to let me test as long as I want, and I'm the only one.
I built like 9 or 10 catapults right before this. So I started this project. This was a 2-month project because I started it. I made the lock that I sent to the lock picking lawyer. And then I had like 3.5 weeks while he did his side of it. So I started this project then. I did the bow design and manufactured it and made it. And this was and then I did the catapults. And then making this catapult was one of the first things I did right when I got finished with those catapults. It's like the last thing that I wanted to do. And I'm really good at it now though. This thing was a champ. The amount of shots that this thing did, this thing must have fired thousands of times. I went back and forth and back and forth. I had it down to a science. What I really needed, what honestly might have been worth doing given the amount of time I spent like loading this and going back to the bow and resetting it and loading it, is actually building a magazine that holds 10 targets or something. That honestly might have been worth it. And then you'll notice there's some unnatural motion of the target. What I actually had was the target had a thin Kevlar line attached to it that stopped it a few inches above the floor. And then that went up to the ceiling and there was a spring. And so that it would launch them when they would come down, they would not smash into the floor and break the target or mess up the balls, the retroreflective markers. And that's why you see it bouncing around. You could maybe use retroreflective tape on the arrows. I didn't try that. It should work. Yeah, that probably would work. You could probably even put like 4 stripes on it and then identify it in the software as an arrow, and it would just handle that transparently.
One that's going to suffer.
As expected, the new code base is chock full of exciting problems. It's really cool looking when it hits
why is it firing
sheet
too early?
Why is it firing too late? Why won't it hit the target when it's sitting still? Why did it one-hit KO my microcontroller? Yeah, there was a bug where it would just like track the target no matter what. I was pretty permissive with my fits. So when the target's like bouncing around and doing stuff, it would like be trying to hit it. And that's why it hit my microcontroller. I eventually just put if it was below a certain height, it just wouldn't track it. And that allowed me to be aggressive with my tracking and tuning, but not do that stupid stuff.
So many bugs.
But it's only a matter of time. We're knocking those bugs out. We fix the microcontroller. We destroy targets sitting still. Now we're getting really close. At this point, I'm pretty sure that... So there's two things that are kind of neat. So you can see, if you look up in the top left, you can see the... let me get the... You can see the high-speed camera going crazy. Not the high-speed, the tracking camera going crazy. So let me show that
Really close.
up in the left corner here. At this point, so every flash of that camera is it acquiring a frame. So the arrow is moving like a few inches and it's collecting like 10 frames on its location. So those cameras are crazy. And then this is a view of one piece of the data that I was talking about earlier. These three balls represent the arrow and the bow. These are the trackers on the bow. This is the grip. And then this is the prediction of where the arrow will go. And then this is the target that it's trying to hit. And so when it would fire, everything was great and it would still miss. And that's why I have concluded that it probably was the Archer's Paradox. And then one other interesting thing maybe that's worth mentioning is that some people have messaged me saying, well, no wonder it's not aiming the right point. Your tracking markers are up here, but the arrow's down here. And what I actually had, and this was really important for even the compound bow, which had 3 markers around the arrow, is I had a special arrow that had a marker on the butt and the tip. And I would put that into the bow, and then I would use that to calculate basically the rigid body transform from these 3 points to where the nock of the arrow is, and then from these points to where the center line of the arrow is. And then that was much more accurate than just trying to measure it with tools or basing it off just the geometry. This measured it very accurately. And so if I changed the grip or messed things up, you would just put the calibration arrow in it and then recalibrate it. And that worked really well. I'm pretty sure the software and the robot are doing the right thing, but the arrows aren't going where they're supposed to go. But I think I know why.
I've been using a recurve bow, which comes out of the box with a fundamental issue. You have to fire the arrow.
Yeah, if you don't know about this effect, there's a video from Smarter Every Day talking about this. The basic idea is that the string is pushing the arrow so that it wants to go through the bow, but for old school bows, the arrow has to go around the bow. And what actually happens is that somehow the arrow bends around the bow and can shoot like in line with the bow where it shouldn't be able to shoot. And it causes all kinds of crazy stuff. People spend a lot of time tuning arrows and all sorts of stuff to try to make the thing very accurate at known distances. And I just didn't want to be bothered with that. And that's why I moved to the compound. There is some of this with the compound, but it is much, much less.
Around the bow. This makes the arrow do crazy things, and even crazier things if you're using the cheapest bow that money can buy. Theoretically, I could calculate what's going to happen and correct for this, but we're just going to buy our way out of this problem.
This is a compound bow. It's very powerful. Oh, that shot right there went. I had been using the recurve with a rubber safety tip on the arrows, which would just bounce off the foam. And I put a rubber safety tip on the arrow in the compound. I really lowered the draw force. You can see the bolts. If you're familiar with compound bows, these bolts are what set the draw force. It's way down. And it just went straight through the bin and out through another bin and destroyed a bunch of stuff. It didn't actually hurt any of my actual things, but it destroyed a bunch of bins. It was pretty funny, but I was pretty annoyed with myself for, I don't know, it's just dumb. Why did I do that? And it shoots arrows really straight. It's pretty much a drop-in replacement for the other bow, except for one problem.
This thing is really heavy.
you can see my retroreflectors. So these are nominally centered around the arrow. There's actually a little calibration disc. It goes around the arrow and you put it in here, and then you can adjust this ring and bolt it down so that it's really close. But then even with that, you can get more accurate with the calibration arrow.
So we're gonna do something about that. If this isn't an aimbot, I don't know what is.
I was really hesitant to put this thing on. I don't know why. It really felt like cheating. When I make these projects, I construct a set of rules in my mind. Like, I'm gonna hold the bow. You know, it's a bow that you can hold, or it's a golf club that's self-contained, or something like that. And having this thing, it felt like it was taking me away from my original goal and sort of undermined it using the steady rest. But I was okay with it because, one, I had to have it. The thing was too heavy. The only way I could not have it is to completely redesign it to be lighter, which wasn't worth it. And then it wasn't actually really helping me be steady so much as it just helped me hold the bow. Like, the steady rest, it is amazing. It is so smooth and floppy, and so you can shake your arm like crazy with it. It just allows me to not drop my arm down after two shots.
This thing supports all of the weight of the bow, so that all I have to do is hold it in place.
This thing shoots so much better than the recurve. So you can actually see.
This kind of feels like cheating.
So much better. It's pretty cool in this shot. You can see the bow locking in on the target and firing if you watch closely. This thing shoots to the right, locks, and then fires. And in the precision mode that it's doing there, the reason it could have fired a little bit earlier, but it waits for the velocity of everything to settle. So the grip, the bow, it wants those to be very close to zero. And it can do the forecasting that I talked about before, where it looks at how the bow is moving, but it is more accurate when you wait for the velocities to settle. So that's what it's doing there. Curve.
This kind of feels like cheating, but we're way past that point. I think it's time for another round of bow versus wife.
Hey, wife.
Whoa, what are you wearing?
It's engineering. What does it look like?
Body armor with a snake?
You ever seen an engineer before? Same thing as before, whoever's closest gets the point.
I brought this. There's one other neat little thing with this. I guess you can't really see it. I had to modify this steady rest. There's a big problem when you take the bow off of it. When there's no weight on it, it just like, bing, shoots up into the air, and it's really bad. You can nail the bow with it, and so there's this part I had to make. Maybe you can see it in some other shots. You can look for it if it's interesting, but it basically allows me to lock and hold the steady rest in a lowered position so that I can load and unload the bow, and that worked pretty well. It did. There's a couple times where it didn't lock, and then the whole thing like exploded like a clock in a cartoon, you know, where all the gears come out and everything. It's just like and like punched me in the arm, but overall it's pretty good.
Speed down and have it running in sharpshooter mode. That's 3 points for the aimbot. I didn't actually do anything, but it feels...
This, you can look up this reference if you would like to see some true culture. I think it's Big Rigs Over the Road Trucking is the game. There's a very famous English misspelling where there's a trophy with 3 handles, which I couldn't find footage of. And whenever you win, it tells you that you're a winner. That's what I'm referencing here.
feels like I won. All right, it works. Let's do stuff.
We're gonna try William Tell again. I have a little apple. Hopefully this is acceptable size to you.
That's not an apple.
It's an apple. And we're gonna shoot.
It's actually
the
a
heck out
plum.
All right, don't move.
of it. No looking William Tell.
Oh,
Boom.
Let's do that again.
When these things finally work, it is so satisfying. And this type of stuff is where I was just blown away by the OptiTrack, because this is the type of thing that if there's any inaccuracy, it just doesn't work. And I was moving the cameras around, I was taking it to the range, and it just worked, and is so satisfying.
Again, I need more. Okay, that's pretty cool. It's time to show what this thing can really do. Moving targets.
So you can see it going for apogee there. It pushes the bow up because it thinks it can intercept and get it. It spanked the vinyl decals off the target. I kept destroying these targets. There was an evolution. The original target was laser cut multiple rings that were painted and then glued to a backing sheet. And I kept destroying them so they got simpler and simpler so that I could make them really easily. Ultimately, it was just some thin plywood that I laser cut with vinyl decals to give it the rings. Normally, I wouldn't bother with the rings, but it seemed important. These lights, let's see if we can see them anywhere. So a really hard thing, yeah, oh gosh. Sorry, I'm bad with these controls. Oh, nice face there. So these lights back here, I got these used. I can't remember what brand they are. It's basically a giant heat sink with some LEDs on it. And I found these used for like a third of the normal price, but these were the only reason that I could capture that high-speed footage. The high-speed camera wants basically all the light. It really wants sunlight. And so getting lights that are bright enough, normally when I'm taking high-speed footage, I have two lights, like 6 inches from whatever it is I'm getting footage of, and the camera stuck with the lights right next to it. And that's the only way I can get enough light. These are so bright, I can actually illuminate the target from behind me and the path between me and the thing. So they're amazing. They're so powerful, and they have some really cool holographic lenses. So you can put a holographic lens in front of it. It's just a thin sheet of plastic, and you can make it be a wide or narrow beam or whatever. They're really, really quite amazing. And they came just in time for this project. I wouldn't have been able to get any of the high speed without them. See the high-speed camera going nuts. That is so awesome. Oh my goodness.
I just love seeing it compute where the target's going to go and then intercepting it. It's so cool.
So that was a case where it couldn't reach apogee, so it just shortcuts it to the side. There is one more thing I really want to see.
He has no idea what's coming. Maybe he does. There's nothing to worry about. We're just going to shoot this tiny apple off his head. To hit William Tell Nano, we have to be able to hit not only bullseyes, we have to hit the exact same spot on the bullseye every time. This is the best that I can do with the bow, so we're not going to be able to do it every time, but we should be able to do it sometimes. Look how close we're getting to splitting another arrow. It wants to real bad. All right, he's got his safety goggles on. Terrible shot. This is just embarrassing. All right, that's what I'm talking about.
Looks like you got him right in the heart.
That actually really messed up my target. It shoved the Lego man into the target and took a chunk out of it. But yeah, it was worth it.
Kill shot?
100%.
Oh yeah, you did. Everything important.
We removed the apple, but it wasn't quite the surgical removal that I hoped for. Let's try it again.
I couldn't believe that this worked. The target that's smaller than the arrow. And this, so I actually put these out of order. This was the first one that I did. I nailed it. And then I did it again, trying to get some higher speed slow-mo because the arrow's going so fast. It's like 3 frames. And yeah, it's crazy. It did slightly nick his head, but pretty cool.
It did remove his arms and legs again, but I think this is about as surgical as we're gonna get.
This bow is really cool, but it could be a lot better. In fact, I'm already working on a V2, which I'll talk about in just a second. Before I get to that, I want to talk about this video sponsor.
I would normally skip the sponsor, but there's maybe some neat stuff to talk about there, so we'll just go through it.
Opportunity that could literally change your life. And I know that sounds really hyperbolic, but I did the thing I'm about to tell you about 9 years ago, and it completely altered the trajectory of my life. So check it out, and you just might change your life.
This is a very unusual sponsor. So this is actually up in Boston. This is at the headquarters for Formlabs. This is the print production room. So they make all these sample parts and things for people. They make a crazy amount of them. And so in this room, there's like 100 or 200, I don't know how many. There's a million printers in here. And sponsorship. It's actually for an opportunity. And it's with Formlabs. It's a really, really cool room. The machines over here, these are, one of these days I'll get my hands on one of these. These are a huge SLA printer. It's called the Form 3L. And it's like, I don't know, by volume, it's like 10 times the volume of the Form 3 or something. They're huge. They're really cool. You can print like computers and monitors and really big stuff on them. But for me, really big functional parts, I think that'd be really sweet.
Around me. All those really nice parts that you see on my projects, those are made on these machines. They're 3D printers. They're some of the best.
The cool thing, I haven't really talked about this in my videos, but the cool thing about these machines is that, so I worked on the design of these and the Form 3. So I was running that program. And when we were designing the Form 3, we made the optical module in it. There's a removable thing that has all the high performance optical crap in it. And this machine uses the exact same optical module as the Form 3. There's just 2 of them instead of 1. And the advantage of that is you get a module that's been designed and tested for like thousands and thousands of hours, and you can just put it in the big machine. You don't have to remake it and retest it. And if you improve it, it improves both machines. So it's pretty neat strategy to get kind of 2 machines for 1. And someone's asking how much resin to fill a tank that large. I think it's about 1 liter, thereabouts, maybe 1.5 liters. It might vary by resin as well. The more viscous ones don't flow as nice. I don't know exactly where it landed, but I think it's about 1 liter.
In the world, I've used one on literally every project that I've done. I actually worked here for 8 years developing these and other machines. I'm up here right now for the annual hackathon where employees build basically whatever they want.
This was really cool. I have thought about getting an SLM printer, but I really need someone to give me one. I can't afford that kind of stuff. This machine is actually, it's moving basically a sheet of glow-in-the-dark film up and down at like 30 or 40 hertz, maybe even faster than that. It's really fast. And this is actually inside of a Form 2 printer. So it's the Z-axis of a Form 2, except for up top, there's an O drive with a really overpowered motor that just moves this thing up and down super, super fast. And then there's a laser galvo scanning out frames at different points in time to draw 3D objects. It's sort of the equivalent of that Jerobeam Fenderson, if you've ever seen the guy that draws on an oscilloscope. I think he had a Kickstarter about it. Same thing, just in 3D. Really, really cool effect to see in real life.
Including some really cool things. But this isn't about the machines, it's about an opportunity. The things that Formlabs engineers are so good, it has led to a lot of success. When I started, there was 10 people. Now there's over 600. This is where the opportunity comes in. It takes all of the engineering disciplines to make these things, and Formlabs is hiring for everything. If you like my projects, the engineering that happens here will melt your brain.
The fuse, my goodness. So many stories. So hard to get that machine working. There's just so much going on.
So just go check out formlabs.com/jobs. The 8 years I spent here were fantastic.
Yeah, those are my
Really one of the
patents,
best
some
decisions
of
that
them.
I've made. I learned so much, I had a big impact on the world, and I worked with amazing people. There's also some pretty nice perks. The only reason I left is I thought the YouTube thing was a 1 in a million opportunity that I would just regret forever if I didn't try it. There is one job I wanted to highlight, which is CTO. This would be running all of the engineering programs. This is a super rare, super huge opportunity.
This is another cool product that I want access to just because I want it, and it would save me a lot of time. This is 5 printers inside of a robot, basically, that can tend them. And so you can send a queue of parts that you want printed, and then this arm will load platforms into them, print them. When it's done, take it out and then wash it, and then load the washed parts into a rack for you to retrieve later. And you just run it like for days and come back to hundreds of jobs, and it's really cool. It's actually surprising how cost competitive this can be with mass production for plastic parts. So the material properties of some of these resins are good enough, if not as good as certain thermoplastics that you'd use for injection molding. And so they cost a little more, but you don't have to make tooling. So this is pretty cool. I don't know. I want one.
If you or someone that you know would be a good fit for this, you can always apply online, but I'll also put a link in the description so that you can reach out directly. So that's basically it. You should work at Formlabs. You can check out all the jobs at formlabs.com.
Okay.
This bow is cool, but I want more. I want to be competitive with real archers.
So someone was asking about this in the comments for the Patreon post, and I did set up all the tracking cameras here. They have an incredible range. They can see basically from where I'm shooting to the target. The tricky thing with setting up all the cameras is that they all have to overlap. So I need cameras looking at me, I need cameras looking at the target, and they need to overlap quite a bit so that they can knit together into one homogeneous volume that I'm tracking. And so it was a bit of a pain to figure out the right arrangement, but once I had the right arrangement, it worked, no problem. And like I was saying before, once they're in the right position, you just put them anywhere. So they're just on tripods, throw them out wherever, wave the wand, and you're good to go. The downside of this is 60 odd feet, maybe 65 or 70 feet. And I want to go longer than that. And there's no way that I can go to like 200 feet or something like that with this setup without a ton of cameras. So I have some thoughts for V2 that I can do this with the cameras. There's also some other ways that I can do it without the cameras. Haven't decided yet, but what I am going to be doing is improving the bow. So I've ordered a much better compound bow. It's a Target bow. Actually, after I posted this, some people offered me a bow. And so I'm going to have a much better bow. And then the key for the really long distance is extreme repeatability for its pointing. And so I'm not going to get into what that would look like here, but it's a completely different design than what I have with this bow. And I think, we'll see, I have to build it. I think it can be substantially better accuracy than this one.
I actually took this bow to a local range, but that's a story.
The first shot that I did at the range, like all the people are there and they're like, oh, this is so exciting. This is so cool. Wow. The technology, it's so good. And the cable for the release got caught in the cams for the compound bow and it popped the string off and everyone's like, oh no. Cause it's like bow destroying event sometimes. It was pretty funny. It was like the hugest like air coming out of the room ever, but they're able to fix it. It's no big deal.
Story for another day. What you need to know is that William Tell Nano is the key to everything.
When you push the target really far away, small errors become big errors. If I want to hit bullseyes at 60 feet or 150 feet, I need to be able to hit this apple every single time at this.
That was actually the origin of William Tell Nano, is backing out the accuracy that I need at a shorter distance to hit very accurately bullseyes at a long distance. It turned out to be a little bit bigger than the apple for William Tell Nano, and so that became my little target to see how well I was doing. And so you can see that I can't hit that every time. I can't hit a bullseye at distance every time, although at the range I was doing pretty reasonable, but not good enough. I want to like be competitive, ideally with like an Olympic archer, but we'll see if I can do that.
This distance. Plus, it's awesome. I think I need to make a version 2, and I kind of have a design in my head of what it would look like. I'm probably going to do that.
Get ready, Legos.
Get ready, Legos. Watch out.
If that or any other crazy things I build sound cool, please consider subscribing. It helps me out, and you'll get...
You can see before I was trying to figure out what the constant force spring should be. This is a string that goes up to the ceiling and back down to a weight, and that acts as sort of a constant force spring. Although it's weird because it pulls my arm up too. That caused some problems, but that was pretty funny. And I guess the final thing,
Get notified when I post new
see it
videos.
here.
If you'd like to support these projects directly,
Yeah, I've had a number of people telling me that the Whisker Biscuit is bad and that a dropper rest is better. Probably at the longer distance, but I just can't imagine that factoring in at the distances I was doing here. So I will not have, just even for the superstitious value, I will not have a Whisker Biscuit next time. I will have a dropper rest.
check out my Patreon.
That's pretty cool.
Thanks for
Yeah,
watching.
that's the little latching mechanism to remove the bow. So that is more stuff on my bow. If there are any other questions, now is your chance to ask. Otherwise, we'll shut this thing down. You get, 30 seconds. Of course, when I'm sitting here waiting for 30 seconds, it's going to feel like an absolute eternity. But, oh well. All right. Well, doesn't seem like there's anything coming in. So if you enjoyed this or you have any improvements for how this could be better, let me know. Otherwise, thanks for tuning in, and I will see you all later. Have a good night, or wherever your time zone is. For me, it's night. See ya.